velocity and speed. We are, whoop, I kicked that on accident. We are inching towards some really important information. So what we're going to be reeling on today is this pink poster. We're going to be hovering over that today. After a while, we're going to be on that yellow poster in the back. We have a little while before we get there. So, if you might ask the question of like, why do we do that trig stuff? Hopefully I'll start to peel back the hood of why we did a little bit of that trig stuff. That way when we get to this like more difficult stuff, we don't like smack you with all the hard stuff at once. We introduce it just a little bit at a time. So, okay.
You made a lot of noise.
It was like 10 seconds after he did it.
No.
Okay. Speed. Is everybody got it? Velocity versus speed notes. This is a joke. This is not a formula.
Shut up.
I wrote it down.
This is Velociraptor is distance raptor over time raptor.
I thought it was just like a special way.
I thought it was like a fancy way to
Yeah.
I just see everybody like furiously writing down the picture. No. Okay. All right. Give me a wonderful drawn picture of Velociraptor. All right. Speed. What is it? Speed is a scalar number. So first piece of candy for today. Somebody help me remind me. What is a scalar number? What you got for me?
A scalar number just has an amount. It doesn't have a direction.
Absolutely. Nailed it. Okay, so when we look at speed, you're looking at speed limits, right? If you're going here on 600, the speed limit is 45. Doesn't matter which direction you're going, north or south.
That's a suggestion.
All right.
We know you don't speed, but
No, not me. Literally everybody else who goes down 600.
Okay.
you're making fun of me.
Notice, and here's the small little distinction I'm going to make, and I'm going to be particular about this class. Notice on the speed formula on the wall, we have a capital D for distance. When we do velocity here in a little bit later, that'll be displacement. Okay, distance over time. If you're new to my class, you won't need to memorize these formulas. Always provided to you. So when it comes to this Friday, we take a quiz over it. That poster stays on the wall. Okay. Now, if Mr. Williams had a super simple definition of speed, okay, I would just say how fast. All right, how fast something moves. Cool. Not too bad, right? You good, Brian?
Yeah.
All right. Sure.
No.
Okay. So let's try this out. There's a reason I'm going to go through this first easy example, and that's because with the magic that is physics, all right, if you keep your units straight, you'll always know what your units will be in the end result. Okay? So what speed is an object traveling if the object travels 3.5 kilometers in 1.25 hours? So when it comes to our formula, we got S equals D over T. You'll notice I write my T's a little funky. All right, I write my T's like this. That way you don't confuse them for addition. All right. You don't have to write your T's special like that, but that's why I write my T's like that. Somebody then made the comment, fourth period, well, can't you use a capital T? Well, no, because capital T is reserved for some stuff later on, like stuff we'll do like after spring break. Oh no, like right before spring break. Okay. Cool. What two pieces of information I got, Brian?
We got the distance and the time.
We got the distance and the time. So looking for speed. What's my distance?
3.5 kilometers.
3.5 kilometers. What's your time?
1.25 hours.
1.25 hours. Here's why I recommend you writing your units in there. Almost all of you, without a shadow of a doubt, I think you get to this point, not a problem. You can even get to the answer of 2.8. However, what's my unit going to be? It's given in my work. Kilometers / hours. Kilometers per hour. Okay. Ready, Brian?
Yeah.
I'm gonna try to kick it. Just for the fun of it. going for Hannah.
I mean,
No, I was paying attention.
All right. I'm gonna do a little bit of math magic for a different example. What's up?
So on the poster, is that capital T just regular like lowercase t or?
That's because this poster, and I was gonna explain it here a little bit. These posters are based off of my ICT class. Other posters, which they don't reference at all, are based off my physics or AP physics. So like if you notice on our physics poster back here, see how we got the T with a little tail? After a while, we're not even gonna use this pink poster anymore. We're gonna be breathing in this realm. And that looks ugly. It's really not that. It's just we gotta learn the bits and pieces to it. Then we get there. Alright? Alright, now I'm gonna show a little bit of the math magic. What if we were doing a different problem, but instead of finding speed, let's say if I was trying to find time. So let's say, speed equals 10 meters per second and distance equals 160 meters. I'm going to do a little bit of the physics and math magic to show you why we put our units in there. Alright, speed equals distance over time. Alright, speed is 10 meters per second. Distance would be 160 meters over t. Alright, I really hope that we do not multiply both sides by 160. Alright, that's like the number one pitfall I see a lot of people do. Alright. Hopefully, multiply both sides by t. 10 meters per second times t. Alright. We good there? Haven't done any crazy math magic yet. I'll be there in a second.
Brian, I'm focusing.
Fantastic. Alright, Avery, you ready for the math magic?
Yes.
Alright. The name of the game in algebra, right, is to get the variable by itself, right?
Yes.
We want to get t by itself. What do you want to do here?
You want to divide 10. Like, so, or yeah. You know what I mean?
Absolutely.
Yeah.
Divide 10.
That's what I said.
Ignore Brian because half the time he either intentionally says the wrong answer or the other half he is wrong. So, okay?
That's true.
So, but we're not going to divide by just 10. We're also going to divide by 10 meters per second. You follow me there? Here's where the magic happens. All right? If you keep track of your units when you're plugging in your numbers, hopefully we can all agree that this would cancel out. This would cancel out, so I'm left with t. 160 divided by 10, well, that's 16. But why am I left with the unit of seconds? We got a meters on top, we got a meters on bottom. And then somebody might go, well, seconds is on bottom. Well, that's 1 over s, which is just s. Follow me there? So, when you're doing these problems, keep track of your units, and your units will cancel if you did the algebra right. Okay. You ready, Avery?
Yeah.
You good with cherry? I think it's cherry. And with your face, that's not good.
Thank you.
did not do a color whatever I wanted.
Can I get a flavor?
Thank you.
If I do a question.
That's always been the case, man. You were in my class over at Muncie Central, and we still did that. You know that's the case. All right. Do you have a question, Alan?
No.
What's about the S?
Well, no.
Okay.
I want to see him do a whole problem.
All right. We good here? Speed is easy. Speed is pretty straightforward. However, we're not going to use it too often because we're going to use velocity instead. We're going to use velocity more often.
Maybe this is why I'm sure.
There's no one.
It was taking out doing whatever you.
Where?
The head of my jab.
Guys, that's recording.
Oh yeah.
It's all right. It's only for you guys. So,
So you're not gonna post it on YouTube?
oh, it will be posted on YouTube, but nobody watches my notes.
I was
anyways.
about to say that day.
It's all right.
You superhero my jab.
I'll buy you two, don't worry.
It's okay. I get like 1,000 views a day, but that's from my other videos. So there's my little humble brag right there.
Show me stamina. For real.
All right, somebody help remind me, what is a vector? What's your vector, Victor? What do you got for me?
It has a direction.
What has a direction?
The law.
The object.
I'm looking for like could be like there's an M word we could use, there's an A word. Yeah, absolutely. It's got a direction, right? It's a measurement, it's an amount, it's a quantity, right? It is something that has an amount and a direction. So if our velocity, all right, is in the x direction, left is negative. If it's in the y direction, down is negative. All right, ready out? Try behind the back. I'm gonna get away from him with that one. Ready?
That was
What?
good. That was good.
Okay.
How much knowledge travels with
Okay.
This is my left hand, not this.
Mr. Williams' definition of velocity. We can go with this big one. It's a rate which an object travels with certain direction. Or I will just put it with how fast
something is going.
with direction. All right.
Going a million miles that way an hour.
Okay. I'm gonna expand upon this little formula down here. Okay. I'll be there in a second. I haven't got there yet. So velocity is how fast you're going with a direction. All right.
Speeds is how fast something is going. Is that what the difference is between speed and velocity?
Correct. Velocity has direction. Speed is.
Okay, cool.
All right. I'm gonna add a little bit off to the side for the notes. Okay. This is like probably the most important thing to write down. All right. X and Y velocities are independent of each other. Okay? So we have to denote them when we need to denote them. How do we denote them? Well, if it's horizontal, we note it as V sub X. Right? This is your horizontal velocity. And it's not affected by something else that is affecting the y velocity. So this is your vert. Y is affecting your vertical velocity. Sure do. Sure?
No, sorry.
Okay, thank you. Can you look at the nurse?
Nurse?
Yep.
Oh no.
Okay.
Please don't.
Okay, y is your vertical velocity. Here's the reason we keep them independent of each other. All right, well, we'll definitely unpack it later on. But what's that thing that holds you down to the ground? Gravity. What direction does gravity work?
Down.
Down, in the y-axis. So your vertical velocity is affected by gravity. So that's why we need to keep them independent of each other. It's because one always has something acting on it, and horizontally, there's usually not anything acting on it unless we act something on it. So we have to keep them separate. Am I good here? Can I go back to the slide? So how do we write our velocity formula? We can write it one of two directions. We could say v sub x or v sub y. Man, I'm falling apart today. What's up, Hannah?
Okay, so what if something was like jumping up and out? Wouldn't it be affected by both?
I'm going to answer your question, but I don't want it to get too far. Because you're going to ask a question where I would answer in like 3 weeks.
Okay.
When you jump up, gravity pulls you down, right?
Yes.
Regardless of how fast you jump over, you will always land at the same time as if you were to jump straight up.
Okay.
So what?
So it's not.
So if I were to throw Brian off a cliff
Yeah.
and shoot a cannonball at the same time, off the same cliff, same height, regardless of how fast I shoot that cannonball, they will hit the ground at the same time.
So
What?
and this is Brian,
Good
and it just
test
falls down, and then this is Avery, or like, sorry, this is a cannonball, and like you throw it, wouldn't it take longer for this?
Nope.
Why?
Physics.
But it's going that way.
Because it's
If it doesn't-
gravity.
What if you throw it up? But like,
If you throw it up, well, here's the thing. By throwing Brian off a cliff and shooting something horizontally, they both have the same y velocities, but they have different x
so
velocities.
you can't shoot the cannon.
What will happen is the cannonball will hit the ground faster overall because it's
Okay.
traveling at an x and a y.
Okay.
Brian will hit the ground not as fast as the cannonball overall.
Okay.
Can we
Instead of
try
going to the
this
ground.
out?
Yeah. Can we
Yeah.
like,
Can we,
test
because
it
like,
out?
I'm
And
more
here's
of
the
a
really
visual
cool part.
person.
Remember that equipment we got, the $12,000?
Uh-huh.
I have equipment to show that exact experiment.
We don't need equipment though.
I think
can
we
do it.
can do Brian in the cannonball.
So, it's in a box back here. Maybe if I can get time, maybe I'll pull it out sooner. I thought I'd have to. But we're going to keep x and y independent of each other. And that's why. Okay? There might be a new triangle symbol you've never seen before called delta. Delta is this triangle symbol. It's just the change. Alright? That's the x2 minus x1 or the y2 minus y1. Alright? That is saying, alright, there is no difference overall of your position. So you could be anywhere. Alright? As long as your change in position is the same, your velocity will be the same. Okay. Good here? You good, Abdul?
Yeah,
You conscious of I?
I was just pressing the fly.
Okay. What's up, man?
What was the delta again?
Delta means change.
Okay.
That's all it is. So the change in y or the change in x.
The flashbacks to
Okay.
chemistry are beginning.
Delta shows up everywhere. Shows up a whole lot more in calculus, right? It's like everything is delta. We delta everything. All right.
Just like this new code. That's right.
I got time. You know, Branson, we'll give this. Let's go with this one. All right, Branson. I want you to answer the first question here. There's two questions here overall. I want you to answer the first question.
At what velocity is an object traveling if the object travels 3.5 kilometers in 125 hours to the left?
To the left, fantastic. All right. I'm going to put v sub 1 because this has two velocities in this question. All right. So we'll put v sub 1. If you want to be more specific, we put v sub 1 in the x direction. If you want to be really particular. Velocity is your change in x over your change in time.
Okay, I got this.
All right. What's your change in x? What's your displacement?
The displacement is 3.5.
3.5?
Yeah.
I disagree with you.
Why?
So that's a fantastic question. What direction are you going?
It says
To the left. So if my displacement's to the left,
and you're not going right, so it'd be negative.
it'd be negative 3.5.
You're not going right.
All right, what's your time interval?
1.25 hours.
1.25 hours. So my initial velocity, or my first velocity in the x direction, what's negative 3.5 divided by 1.25? Come on, man, you know on the top of your head? I don't know either. Let's go calculate.
2.8.
2.8? That sounds about right.
Negative.
Actually negative.
Negative 2.8.
Kilometers an hour.
Branson, what's your units?
Kilometers an hour.
Kilometers per hour. km/hr. What would be my velocity if I returned in another 1.25 hours overall? Branson, you ready?
That's not it.
Avery, my throws are on point. If I hit you with a throw, it'd be intentional.
Yeah, watch out.
I don't know.
Should
It's
be talking
dry.
about Canada and Avery.
But sometimes.
Abdul, you ready?
Yeah.
All right. I go 3.5 kilometers out. I come back in. What's my displacement? Killing me, dude.
Yeah, Falcon's gonna go.
I go 3.5 kilometers, and then I go back. Riley's got it. Riley, what is it?
0.
0.
I told you. Oh, like,
Oh. 0. Because I stopped where I started.
I wanna see what he typed in.
I thought you were. I thought you went back 2.8.
Where did you get 2.8?
Right there.
I feel like he was doing something on the
No, that's your velocity. Yeah.
Like, 7, bro, I got it.
But if it's a distance.
What's in the copy?
That's what I thought.
But you're not gonna use the 2.8.
Yeah,
Either way.
I thought I had to use it.
It's okay. Just say you're wrong.
You can still hold it like.
Because you went left, negative, and then you went right, positive. As long as you stopped where you started, your average velocity overall is going to be 0. Because since you had to go left, you have to come right to counteract it. Okay? You get there, Bill? Okay. You're embarrassed? Okay. We're here to learn, right?
Yeah.
I really just appreciate you guys are all to rise each other. It makes sure we're all on pace and ready to roll. Jackie's bored.
I feel like Jackie is the most mature person in here.
Hey, I take personal
Allie.
offense to that.
Maybe Allie. I don't know her that well.
Okay. Are we okay here on this question?
I walked into this and everything makes perfect sense.
I'm going to step it up just a little bit. Okay? Step it up just a little bit. We're now going to take our problems and involve the trig component to it. Okay?
Oh.
So,
And you lost it.
here's what I'm talking about. I'm going to draw a triangle.
Make Avery do it.
If you shoot or kick or launch anything at an angle, all right, you're going to have it give it some velocity. All right, some velocity overall. There will be an x component, so I'm going to say v sub x, and a y component of those velocities. Hopefully now you get a little bit of foresight. This is going to bleed into our rocket project. All right, I talked about it on Friday, right? You're trying to figure out what angle is best to have your rocket go furthest in the x direction. Well, then you might have the question, well, we're just going to shoot at a small angle because we're going the fastest in the x direction. Well, then gravity takes over. But I digress. I'm taking it. Okay. You got your velocity. We're going to break it into its components using some of that trig. So we're looking for the horizontal and vertical velocity of the ball once it's kicked. We know we kicked it at 10 meters per second. Okay. Now we got to put a little bit of our trig in there. So my angle is 30 degrees. There we go. We'll do some more trig. Hey man, how do you feel about that trig? No? You just don't care or just no? You don't like it? Okay. Hopefully after a while you get to learn like this. Abby, how you doing? Fine? Can you see the picture okay? Yeah. Okay. We got angle 30. What is Vy when looking at your angle? Is it opposite, adjacent, or hypotenuse? It's your opposite. And regular V, the velocity of the ball, what's that going to be? Hypotenuse. And X is going to be adjacent. Fantastic. So we're going to look for, I'm going to look for Y first. V sub Y. What trig function do you want to use? Sine. Was that a guess or did you figure it out right there? Did you guess or did you got it? Were you confident with sine? I don't know. Let's make sure we're all on the same page here. So let's take a step back. We got SOHCAHTOA. Try that again. Abby helps us out a whole lot, noticing which part of the triangles we have. If we're looking for the y component, and we have your velocity overall, it means we have opposite and hypotenuse. Which of these three has opposite and hypotenuse in it? That's sine. So sine of theta equals opposite over hypotenuse. Cool. Okay. Ready to go, Kent, for Greek? Alright, plug and check my numbers in. We got sine 30 equals opposite, I'm going to call Vy. Hypotenuse, I'm going to call 10. Multiply by 10.
Where did you get 10?
It was in the.
Oh,
it was in the
pretty.
Wow, that's a pretty number.
Hey, stop.
That was so great.
Brian, I do want to let you know, if there's ever an argument between any of these students, you are going to be the least person I'm going to like.
Yeah.
You're the bottom of the totem pole, all right?
Alright, that's fair.
You can be the only person with the right answer, and I'll still defend them.
Yeah.
That's
Alright.
fair.
Multiply both sides by 10.
You get 5.
5.
Yep, sine 30 is 1/2. If you have no clue what I said, it's okay. 5 what?
Meters, because your speed is meters per second, so therefore
Meter.
your measurement would be meters.
Close. Meters per second, so.
Because that's the only label we have for the 10.
Well, we're looking for velocity, right?
Yeah.
We're looking for velocity in the y direction. What is
So
the
we're not
measure?
looking
What is
for
velocity measured in?
measurement, we're looking
Meters per second.
Okay.
Okay.
So it's got 5 meters per second vertical.
Yes, so it's going upwards 5 meters per second.
5 meters per second.
Hannah, you ready?
Are you throwing it to me or
Yep.
Brian?
Not
I
Brian.
got it.
Why would you throw it to me?
Yeah, so
I just made fun of you.
I know that 5.
You're a man.
Is everybody? Well, hold up. Well, before we get personal about it, let's chill. All right. Is everybody good on the vertical component? Okay.
Now we have to find the horizontal.
Now we got to find the horizontal. What trig function am I going to use to find the horizontal component?
Cosine.
Cosine, says Jay on the front. Cosine theta equals what?
Adjacent.
Adjacent over hypotenuse.
Your adjacent's what you're solving for, your hypotenuse is 10%.
So we got cosine 30
Equals
equals
Vx.
Vx over
What is it,
10.
meters per second?
multiply both sides by 10. We get
10.
10 cosine 30, which is going to be some ugly number.
8.66.
8.66. That sounds great. And what's the unit?
Meters per second.
Meters per second. Justice, how you doing with this?
Where's my candy?
Danica, how you doing with it? Good. It's part of school, right? So learn. Hey, look at that. I'm doing my job. Okay. Any questions about this one? I'm gonna zoom out a little bit.
No. Is this what our homework's gonna be on?
Yes.
Word.
I could have said something very mean
Word.
there, but didn't.
She said
David, you good, man?
Way to
Okay.
come with kindness.
What if we go the other direction with it? This is the last example for today. What if you have a component and you're trying to find the velocity?
Oh, you gotta have something to measure speed by. You have to have the distance and a measurement. And that's how you get speed. Determine velocity by the direction it's going.
V sub x, V sub y,
Are you saying V or V?
V. As in Venus. Allison, how you doing with this? Good. Are you like slowly, like low key liking physics after a while? You guess? Didn't ask.
I like it.
Every day is the first day she walked in.
Alright, what information am I giving in the question? Brian, do you want your shot of candy?
Yeah.
Alright, I want to immediately boo you if you get anything wrong.
We got the degree.
You got your angle? Sure. What's your angle?
45.
45.
And then we got the velocity, which is v. It's 200.
Boo! Boo!
I was taking a while.
Read the question. Don't just look at the numbers and think you know.
Oh, it's vy.
Dude. Try again.
Oh no, that's vertical. It's va.
Oh, man.
Sorry.
This is so great. You're making fun of people earlier. Now you're just making it look like
No,
fun.
nobody said anything.
Yeah, but I got it right.
Be quiet.
Oh, hey, good job, man. That's, I only made fun of once. Avery didn't say anything. She did.
Here you go, Brian. Ready? I'm going to try to kick it. I want to hit Evan.
You missed me.
Oh,
No, you're rubbing at me again.
Hey, if he ever hits someone, it's intentional.
That's if I throw it. I've been throwing candy for a while. I haven't been kicking it for very long.
When was the last time you played soccer?
Saturday.
Do you have a club that you go to every Saturday?
Alright, there's my angle 45. What parts of the triangle do I have? Jason. Jackie, help me out. Yeah, Jason the angle, and what are we looking for? We're looking for the hypotenuse. So we got adjacent. We're looking for hypotenuse. So Jackie, what trig function am I going to use? Cosine. So cosine of 45 equals what over what? You got it for me, Jackie? Over what? Just V. Okay. The only thing I want to tweak, what you just told me, you said this was miles per second. It's meters. Miles is MI. It's a super small thing. Okay.
Hold up. If you're going 200 miles, you got to be going like Mach something.
John Ranch, you good?
Maybe they're in a jet.
200 times 60. You'd be going 12,000 miles. You'd be
All right,
going
so we're-
720,000 miles.
Mister, I don't have any notes out. All this is just mentally banked. What are you gonna do here?
Okay.
Okay.
So you'll times v to both sides.
Sure, fantastic.
720
But you didn't answer the rest of the question.
or an hour.
What else is gonna happen?
So you'll do cosine 45
Okay.
divided by 200.
Okay, as far as like what I get to overall, so I got V cosine 45 equals 200 meters per second. What am I gonna do now?
Times cosine 45.
And
Divide.
divide cosine 45. So V equals 200 divided by cosine 45. What in the world's that giving me?
0.84.
280 something, right?
Yeah, 282.
282.
0.84. In my head. Like that.
What's the unit there, Brian?
Why can't you round it?
Meters per second.
You can. Just as a quick reminder, when it comes to your homework questions, okay, you shouldn't have to round unless I specifically ask you to, and I'm pretty sure you don't have to round on any of these ones. So if you get a weird, funky answer, you know you probably did something wrong. All right? I'm going to take that back. I'll double check on that. I'll look at the homework. Yeah.
Okay, so I did this just out of pure curiosity. If you were going 200 miles a second, you would be able to circle the Earth 28.91 times an hour.
Sure. Sounds about right. That's over Mach 1. It's over the speed of sound.
That's over Mach 2.
What's Mach?
Mach is the speed of sound. So if jet goes Mach 3, it's 3 times the speed of sound.
Wait, I'm gonna.
What's up, Anna?
How fast is Mach?
So V, if there's no label on it, is the hypotenuse?
V is whatever the object is traveling.
Okay.
So because it could be straight up, it could be whatever.
The speed of sound is 767 miles an hour.
What's the speed of light?
Infinite. You can't measure the speed of light.
We can very accurately measure the speed of light.
How?
Galileo did it like a couple hundred years ago. All right, any questions? All right, here's what I have for you. Tomorrow we're gonna do a lab.